Hello dear students, welcome again to your geometry class. My name is Faridullah Mazai and today we are going to study corresponding position of a line and a circle. Dear students, in here we have three cases. First case, if a line and a circle do not have any common point. Second case, if a line and a circle have only one common point. And third case, if a line and a circle have two common points. So dear students, at first I am going to tell you about first case. If a line and a circle do not have any common point, on that time D will be greater than R. What's D and what's R? D is distance between center of the circle up to line, and R is radius of this circle. So when D is greater than R, on that time you can say that line and circle do not have any common point, or line is located outside of the circle. Second case, if a line and a circle have one common point, and that time D will be equal with R. You can see in here in this shape, from center up to line we have D, and this radius of the circle, they are equal with each other. So when D is equal with R, on that time line and circle have one common point, and also we can say that line is tangent with the circle, and this point is called point of tangency. Point of tangency. Third case, if a line and a circle have two common points, on that time you can say that line intersect the circle, and also R will be greater than D. You can see in here, from center of the circle up to line we have D, and this is radius of the circle. You can see that R is greater than D. So when R is greater than C, you can say that line intersect the circle. So dear students, from shapes we can easily identify these three cases. So how do we identify these three cases from the equation of circles? So in here we have two ways. First way, we must find D and R. After that we must check them with each other, that which one is greater and which one is equal. So we must check these three cases. Second way, we must find x or y from the equation of line. After that we must put that value instead of x or y in the equation of circle. After that we must find delta. I am going to solve some examples in these two ways. First example, examine the position of the circle, this circle with these two lines. So now, at first I want to find A, B, and R. So in here we have standard equation of circle, which is x minus a square plus y minus b square, which is equal with r square. And in here we have equation of the circle, square plus y plus 3 square is equal with r square. So in here we have minus 2 and minus a. It means that a is equal with 2. Also in here we have minus b, and in here we have plus 3. It means that b is equal with minus 3. Also, so this one is 25. So here we have r square, and here we have 25, which means that r is equal with 5. So now, for finding distance between a point and a circle, we have a formula which is like this. D is equal with absolute value of ax plus by plus c over square root of a square plus b square. So now I am going to find the distance between center of this circle and this line. So how do we find? We can use this formula. So in here we have D is equal with, in here we have x, which is equal with 2 times a is the coefficient of this x, so 2 times 3, plus b is equal with minus 3 times y is equal with minus 3, I'm so sorry, y is equal with minus 3, b is equal with minus 4, and y is equal with minus 3. So minus 3 times minus 4. Also c is equal with 12 plus 12 over square root of 3 square plus minus 4 square. So when we simplify this one, we will get D is equal with 2 times 3 is equal with 6, minus 3 times minus 4 is equal with plus 12. Also in here we have plus 12, and square root of 3 square is equal with 9, and 4 minus 4 square is equal with 16. So when we simplify this one, we will get 30 over 5. 30 over 5 is equal with 6. It means that D is equal with 6, which is greater than R. R is equal with what? R is equal with 5. So we said that when D is greater than R in here, when D is greater than R, we can say that line and circle do not have any common point. It means that this circle and this line do not have any common point. Second question. Again, I'm going to find distance between this circle and this line. I'm going to use this formula. So in here we have 3 times x is equal to 2 plus 4 times y is equal to minus 3 minus 19 over 3 square plus 4 square. So D is equal with, when I simplify this one, 2 times 3 is equal to 6, minus 3 times 4 is equal with minus 12 and minus 19, absolute value of this one, over this one is equal with 5 over 5. So D will be equal with 25 over 5. 25 over 5 is equal to 5. It means that D is equal to 5, which is equal with R. R is equal to 5. So when D is equal with R, on that time we can say that line and circle are tangent with each other from this case. So this circle and this line are tangent with each other. So now I'm going to solve some examples in second way. Second example, examine the position of this line and the circle. So we studied that in this case we must find x or y from the equation of line. So 1 minus x minus y is equal with 0. So y will be equal with x minus 1. After that we must put the value of y instead of y in the equation of circle. So we have x square plus y is equal to x minus 5, x minus 1. X minus 1 square minus 6x plus 7 is equal with 0. Now I am going to expand this one. X square plus x square minus 2x plus 1 minus 6x plus 7 is equal with 0. So x square plus x square is equal to 2x square. Minus 2x and minus 6x is equal to minus 8x. Plus 1 and plus 7 is equal to plus 8. Equal with 0. After that we must find delta. Delta is equal to b square minus 4ac. So in this equation, b is equal to minus 8, a is equal to 2, and c is equal to 8. I am going to put these values in here. Delta will be equal to b square. It means that minus 8 square minus 4 times a is equal to 2 and c is equal to 8. So now I am going to simplify this one. Delta will be equal to minus 8 square is equal to what? 64, and 4 times 2 is equal to 8. 8 times 8 is equal to 64 minus 64. So delta will be equal to 0. So we study that when delta is equal to 0, it means that line is tangent with the circle. Dear students, this was our today's lesson. If you have any problem or any question about our today's lesson, you are comment us. Also, if you have any suggestion, you can comment us. See you soon, inshallah. Goodbye.